Okay, here we have a nice question from the Core 2 paper. So we actually can use calculators. I actually don't have one next to me, so this could get interesting, but we'll do our best here. Okay, so we have a nice little graph, so it looks like we're going to be eventually finding the area in between here. But first off, it asks us for the curve y is equal to 2x to the 3/2 power, which is this bottom one. We want to find the derivative when x is equal to 4, so the rate of change right there. So with that, should hopefully be simple enough. So dy dx is the nice little power rule. So dy dx is going to be 3/2 times the 2x to the 3/2 minus 1, which in this case is 2/2 power. The 2's drop out, so we are left with 3x to the 1/2 power, and that is the derivative. So that's nice. And when x is equal to 4, we're going to have the square root of 4, because that's what this 1/2 power means square root. The square root of 4 is 2. So dy dx is equal to 3 times 2, which is 6. And that's what they wanted. So we must see that 6 is there. It's important to note, though, if we're thinking about, no, this is good. Okay, so that's the answer for part A. Number 1. Part A, number 2, find an equation to the normal to the curve at y is equal to 2x to the 3/2 at the point A. So again, that's that same point there. So we need to find a couple of things there. First off, we need to find the gradient. Well, if this is a 1 and this is the rate of change, then for a part 2, then the gradient is going to be negative 1/6. Why? Well, because this rate of change in the first one is the gradient. So the gradient there is 6. And so if we want to find the normal, it's going to be a negative 1/6. And you can see by my sort of crude drawing there, it's definitely a negative gradient there, and it's more gradual, so it's definitely going to be a fraction. So we're going to have this. Now the only thing we need is a y value. Well, we know that if y is equal to 2x to the 3/2 power, we already know that x is equal to 4. So y is going to be this. Following the order of operations, here I'm going to have the square root of 4, which is 2. 2 to the 3rd is 8. So 2 times 8 is 16. So using one of my favorite formulas for a line, brackets x minus x1, we replace the y1 and x1 with points. And in this case, they are y values. So y minus 16 is equal to the gradient, negative 1/6, x minus 4. And actually looking at the mark scheme and looking at the question, they don't specify what type of equation they want it in. And on the mark scheme, they actually have this written. So good news is we don't need to simplify this as if it were some other questions. This is our answer for part A, number 2. That's pretty awesome that we don't need to do any algebra to waste our time. We already got the full marks just by doing this nice little plugging in. So that's the answer for A2. If you want to look over the steps, feel free to pause the video, rewind, do whatever. I'm going to get ready for part B. All right, so part B is we want to integrate this, 8x to the 1/2. So that's actually the top line there. So for part B, number 1, we're going to integrate 8x squared, 8x to the 1/2, sorry, with respect to x. So what we're going to do is we're going to have 8x to the 1/2 plus 1, which is going to be 2 halves. So that's going to be O to the 3/2 power, and this is going to be over 3/2. And because we just integrated, don't forget about plus c. Never, ever, ever will we leave something like this where we have a fraction and a fraction. It is disgusting. But remember, division is multiplication of the reciprocal. So really this is 8x to the 3/2 power times the reciprocal, which is 2/3. So that is plus c. That is 8 times 2, which is 16. So we can write this as 16 over 3 x to the 3/2 power plus c. Just want to note here, obviously we wouldn't dream of excluding the plus c, but if we forgot this for this type of question, the mark scheme actually says that it's okay. But the mark scheme does also note that this coefficient must be simplified, so we can't leave it as 8 over 3/2. That will lose you marks. Okay, B, number 2, find the area of the shaded region. Boom, right there. So that's actually nice because we've already found this area. So what I'm going to do is I'm just going to save this off to the side for now. Whoops, no. There we go. So save that off to the side, get rid of this other stuff there. It's not what I want to draw. Okay, so find the shaded region. So if we want to find the shaded region, that is going to be where they intersect. So they intersect here at 0 and then here at the point A, which is 4. So we are going to be basically integrating from 0 to 4. And this is going to be the top function, which is 8x to the 1/2 dx minus the integral of the bottom function, which is 0 to 4, same 2 points, of 2x to the 3/2 dx. And so we can integrate both of these. So 8x to the 1/2, we already did that, so that is 16 over 3 x to the 3/2, and we can evaluate this from 0 to 4, and we're going to be subtracting the values here. So if we integrate this, which I don't think that we did, so I will do this off to the side real quick in green. We're going to integrate this, so this is going to be 2x to the 3/2 plus 2/2 over, I can see that this is going to be 5/2. So same deal. We're going to have 2x to the 5/2, and instead of dividing, we're going to multiply by the reciprocal of 2/5. So that is going to give us 4/5. So that's going to give us 4/5 x to the 5/2. And again, evaluating from 0 up to 4. Okay, so what we're going to do here is we're going to actually plug this in. So 16 over 3, 4 to the 3/2 minus pretty much 0. And then minus, I'm going to do some big brackets there, 4/5. Plug in the 4, 5/2, minus again 0. 0 and 0, not a big deal. So here we're going to have 16/3, and this is the square root of 4, which is 2. 2 to the 3rd is 8. So the 8 times the 16, this is why we need that calculator. So 128. I should know that, but I haven't had my tea yet. So 128 to the 3rd. Minus the 0, we don't really care about that. Minus here, this is going to be 2 to the 5th, which is 32. 32 times 4 is really the same thing as 64 times 2, which is also 128, but now we have fifths. Any year 9 student will tell you we cannot subtract these fractions unless we have a common denominator. So that common denominator is going to be 15. So we're going to multiply this by 5 over 5 and this by 3 over 3. So 128 times 5, that's going to be 640 over 15, minus 128 times 3, which is 384 over 15. Make sure that's equals. And now we can actually do this. So 640 minus the 384 is 256 over 15. That's the answer. That's a 6, not a C. That's the answer for the area. Oof, all that work was worth 4 marks, but it was worth it. Okay, and now finally describe a geometrical transformation that maps the graph of y is equal to 2x to the 3 halves onto the graph of this. Well, if you look at it, maybe I can rewrite this just so you can see. So y is equal to 2 brackets x plus 0 to the 3 halves. So originally it's just x plus 0, but now they have this x plus 3. So what's changing there? Well, for all these x values, so say here, you have to get, how do I want to word this? You want to add 3 to these. So instead of it being at this point, you need to add 3. So we want to set up our vector there. So that's going to be a minus 3 because we need to move 3 to get to that point. But everything else stays the same. There's a 2 there. There's also a 2 there. We're not moving up on the y at all. So this is just going to be 0. And that's it for the transformation. Did you need to draw this out, write this out? Absolutely not. You could have just left this. But in case you're not sure about transformations, I wanted to write this out to see what actually changed. And really was only this x movement of minus 3. So that was it for a whole bunch of marks and a good Core 2 question. If you have any questions of your own, feel free to leave a comment.